Dear students, today we start the general methods of preparation for aldehydes ketones. Fifth general method. Like last class, we discussed about 1, 2, 3, 4. 4 types of general method of preparation. Today we will discuss number 5. Types of general method of preparation. This is number 5. From carboxylic acids. From carboxylic acids, CARBOXYLIC, carboxylic acids. How we can get an aldehyde or a ketone from a carboxylic acid? That is, from carboxylic acid. When a carboxylic acid is passed over manganese oxide, when a carboxylic acid is passed over manganese oxide at 300 degrees centigrade, then an aldehyde is formed. Similarly, when a carboxylic acid, depending upon the nature of the carboxylic acid, an aldehyde and a ketone is formed. So, if you take formic acid, when formic acid is passed over manganese oxide, formic acid is your HCOOH, it is your formic acid. When it is passed over manganese oxide, MnO, at 300 degrees centigrade, then formaldehyde is formed. Formula for formaldehyde is your HCHO, formaldehyde plus carbon dioxide, CO2 plus water is your H2. So in order to balance it, you have to multiply 2 here. So 2 molecules of formic acid, 2HCOH, here HH, 2H multiplied with 2, 2 to 4, here it is 1, 2 to 2, 4. And the number of carbon atoms, here it is 1 multiplied with 2, 2, here it is 1, 1, 2. And the number of oxygen atoms, 1 plus 1, 2, 2 to the 4, here 2 plus 1 plus 1, 4. It is your formaldehyde. Formaldehyde, FOA, MlDeHYD, formaldehyde, it is your formic acid, FOA, MiC, formic acid. So when formic acid is passed over manganese oxide at 300 degrees centigrade, then formaldehyde is formed. If you take, suppose you take acetic acid is your CH3COOH, it is your acetic acid. When acetic acid is allowed to pass over manganese oxide at 300 degrees centigrade, then ketone, that is acetone is formed. Acetone is your CH3 plus carbon dioxide plus water. In order to balance it, we have to multiply 2 here. So it is your 2 to 1 carbon atom is another carbon, 2 carbon atom into 2 to the 4, 1, 2, 3, 4. Oxygen is your 4, 2, 3, 4. Hydrogen is your 3 plus 1, 4 to the 8, 3, 2, 3, 6 plus 2, 8. It is your acetone, acetone. It is your acetic acid, ACETIC, acetic acid. But if you take the mixture of formic acid and acetic acid, when both formic acid and acetic acid mixture is allowed to pass over manganese oxide, then you get higher number of aldehyde, like that is your acetaldehyde can be formed. In similar manner, dry distillation of calcium salt. When calcium formate is dry and distilled, then formaldehyde is formed. When calcium acetate is dry and distilled, then acetone is formed. But if you take mixture of calcium formate and calcium acetate, then acetaldehyde, higher member of an aldehyde series, second member, that is acetaldehyde is formed. Similarly, from carboxylic acid, when a carboxylic acid is allowed to pass over manganese oxide at 300 degrees centigrade, then an aldehyde or a ketone can be formed. If you take formic acid, depending upon the nature of the carboxylic acid you take, you can get the product. If you take formic acid, when formic acid is allowed to pass over manganese oxide at 300 degrees centigrade, then formaldehyde is formed. If you take acetic acid, when it is passed over manganese oxide at 300 degrees centigrade, then acetone is formed. Similarly, if you take the mixture of acetic acid and formic acid is your CH3COH, it is your acetic acid, and formic acid is your HCOH. Mixture of 2 carboxylic acid, one is your formic acid, another is your acetic acid. It is your acetic acid acetic acid. SCOH is your formic acid. Acetic acid plus formic acid. If you take acetic acid and formic acid and allow to pass over manganese oxide at 300 degrees centigrade, then we get acetaldehyde, the second member of an aldehyde series, that is CH3CHO plus carbon dioxide CO2 plus one water molecule H2O. It is your acetaldehyde, ACTALDEHYD. Then come to the balance part. Here the left hand side, that is the reactant side, contains 1, 2, 3 carbon atoms. Right hand side, product side, contains 1, 2, 3 carbon atoms. Count the number of oxygen atoms in the left hand side. 1, 2, 3, 4. It is 1, 2 or 3 plus 1, 4. Then count the number of hydrogen atoms. 3 plus 1, 4, 5, 6. It is 3 plus 1, 4 plus 2, 6. So this is about from carboxylic acids. We can prepare an aldehyde and a ketone from a carboxylic acid. This is your fifth general method of preparation. Then we come to the sixth number of general method of preparation, that is number 6, from alkynes. From alkynes. ALKYNES, from alkynes. You know that an alkyne is a series of organic compounds containing carbon-carbon triple bond. From alkynes, how we can prepare an aldehyde and ketone. And when an alkyne is treated with, or when acetylene, alkyne first member is acetylene. When acetylene is treated with acidified mercuric sulfate solution. When acidified mercuric sulfate solution means when mercuric sulfate reacts with dilute sulfuric acid, acidified mercuric sulfate solution produces water. So this reaction is otherwise known as hydrolysis also. So when an alkyne is hydrolyzed, or when an alkyne is treated with acidified mercuric sulfate solution, then first when acetylene is treated with acidified mercuric sulfate solution, then vinyl alcohol, an unstable compound, is formed, which tautomerizes to form an aldehyde, that is acetaldehyde. Your first come to the what is your acetylene. Acetylene is your CH triple bond CH. It is your acetylene. When it is treated with acidified mercuric sulfate solution, but the reaction hydrolysis, HOH, water molecule, which comes from acidified mercuric sulfate solution. Mercuric sulfate is your HgSO4. It is your mercuric sulfate solution plus dilute sulfuric acid, dilute H2SO4. When mercuric sulfate reacts with dilute sulfuric acid, that is a water molecule is produced. Then this water molecule reacts with acetylene. Direct hydrolysis is impossible. Here this hydrolysis is carried out in presence of acidified mercuric sulfate solution. When acetylene is hydrolyzed in presence of, or when acetylene reacts with in presence of acidified mercuric sulfate solution, first vinyl alcohol is formed. Vinyl alcohol means and the triple bond. Out of a triple bond, one is sigma, other two are pi. A single bond always represents a sigma bond. A double bond represents one sigma and one pi. A triple bond represents one sigma and two pi bond. Pi bond containing compounds or pi bonds easily ruptures when addition reaction takes place, because pi bonds are weaker bonds as compared to the sigma bonds. As you know that a sigma bond is formed due to the linear overlapping of half-filled atomic orbitals, while a pi bond is formed due to the lateral or sidewise overlapping of half-filled orbitals. As the extent of overlapping is minimum in case of a pi bond formation, so pi bond is generally a weaker bond as compared to the sigma bond. Whenever addition reaction takes place, this pi bond easily ruptures or easily breaks. This comes to this, as it is a triple bond. Out of a triple bond, one is sigma, other two are pi. So whenever addition reaction takes place, so water is added with water acetylene, so one pi bond ruptures or breaks. CH2 double bond CH2 is formed. CH2 double bond CH single bond OH. This group CH2 double bond CH single bond, CH2 double bond CH single bond. This group is called vinyl. If you write OH here, it represents vinyl alcohol. If you write Cl here, it is your vinyl chloride. So it is your vinyl alcohol. It is an unstable compound. It is your vinyl alcohol. Vinyl alcohol is an unstable compound. Unstable compound. It tautomerizes. Tautomerizes means shifting of protons. Here hydrogens comes to the left, right hand side to the left hand side. It is a reversible reaction. It is a tautomerizes. 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 That means shifting of protons. This hydrogen comes to the extreme right, to the extreme left. As a result, CH2 becomes CH3. CH3 and this double bond ruptures breaks to form a single bond. CH3 single bond CHO. It is your acetaldehyde. An aldehyde, that is acetaldehyde. So an aldehyde can be prepared from acetylene and alkynes. This is your acetaldehyde or aldehyde can be prepared from acetylene. If you take methyl acetylene, the second member of acetylene, that is CH3 single bond C triple bond CH. It is your methyl acetylene, common name is your methyl acetylene. It is your methyl acetylene. Its IUPAC name becomes methyl ethyl propane pro YL or propine. When methyl acetylene is hydrolyzed, HOH in presence of acidified mercury sulfate solution, that is H3SO4 plus dilute sulfuric acid. Dilute H2SO4. Then this triple bond ruptures breaks to form CH3. Here it is an unsymmetrical compound. Look at this compound. Acetylene is a symmetrical compound because both the left hand side and right hand side of the triple bond contains same group, that is similar or same number of atoms. But methyl acetylene, left hand side contains 2 carbon atom, 3 hydrogen atom, but right hand side contains only 1 carbon atom and 1 hydrogen atom. So it is an unsymmetrical compound. It is an unsymmetrical compound. Here it is addition reaction precipitation. So here Markovnikov's rule is strictly followed. Markovnikov's rule. This rule states that whenever addition reaction takes place, as your methyl acetylene is added with water, or water is added to methyl acetylene, as it is an unsymmetrical compound, here acetylene is a symmetrical compound, but methyl acetylene is an unsymmetrical compound. Whenever addition reaction takes place, then the negative part of the addendum is your water molecule. Your H is delta plus, or plus here it is minus. Negative part of the addendum or reagent molecule will go to that carbon atom. This OH minus part is your negative part, H is your positive part. This OH minus part will come to that carbon atom, which contains minimum number of carbon atoms. So it will directly come to this carbon atom. As a result, CH3 single bond C single bond OH is formed, and this triple bond easily ruptures or easily breaks to form a double bond CH. This H comes to this end, CH2 is formed. It is an unstable compound, inorganic compound, an unstable compound. Double bond when linked with single bond OH, it is called an inorganic compound. So it is an unstable compound. It is tautomerizes. Shifting of protons occurs. Tautomerizes. TAU, tautomerizes. This hydrogen comes to this position to this end. As a result, CH3 single bond C single bond O single bond CH3 bond. CH3 you should have to write single bond here because the valence of carbon atom is 4. In order to satisfy the tetravalence of carbon atom and divalence of oxygen atom, you have to put a double bond in this position. So it represents acetone, ACTON. So when acetylene is hydrolyzed or when acetylene is treated with acidified mercury sulfate solution, first an unstable compound vinyl alcohol is formed. Vinyl which tautomerizes or vinyl alcohol tautomerizes to form acetaldehyde. Similarly, acetone can be prepared when methyl acetylene is hydrolyzed in presence of acidified mercuric sulfate solution. This reaction proceeds through Marconi rule, or it strictly obeys Marconi rule, as methyl acetylene is an unsymmetrical molecule, but acetylene is a symmetrical compound. As it is an unsymmetrical compound, when our addition reaction takes place, when water is added to this system, or water is added to methyl acetylene, then the negative part of the water molecule is reagent or addendum molecule. Out of this HOH, OH is your negative part and H is your positive part. This negative part, OH minus will come to this carbon atom and H will come to this carbon atom, because it will form Cl3 single bond C, single bond OH, and this triple bond polarization break to form a double bond to form CH2. It is an inorganic compound and it is an unstable compound, and it will tautomerize to form acetone. In this process, during this process, hydrogen atom from the hydroxyl part move to the CH2 group, as a result CH3 is formed. In order to satisfy the tetravalence of carbon atom, you have to put a single bond here, but in order to satisfy the tetravalence of this carbon atom, you have to put a double bond, which explains an acetone is formed. So acetylene on hydrolysis produces acetaldehyde, and methyl acetylene on hydrolysis produces acetone. First one does not obey Marconi rule, but second reaction strictly obey Marconi rule, because it is an unsymmetrical compound. This is regarding from alkynes. Then come to the number 7. Then come to the number 7. General method of preparation from alkenes. Alkenes are the series of organic compounds or hydrocarbons containing carbon-carbon double bond. How you can prepare an aldehyde or a ketone from an alkene? You know that in factor classes, you know that alkenes on ozonolysis can produce an aldehyde or a ketone. Depending upon the nature of the compound, an aldehyde or a ketone can be formed. But alkene on ozonolysis can produce an aldehyde or a ketone. Comes to the first one. How you can prepare an aldehyde? Suppose we take ethylene. Ethylene is your CH2 double bond CH2. Ethylene on ozonolysis. When ozone is added to ethylene, when ethylene reacts with ozone, first an unstable cyclic compound, ethylene ozonide is formed, which on hydrolysis in presence of zinc to form formaldehyde. Ethylene is your CH2 double bond CH2. It is your ethylene. On ozonolysis, means addition of ozone O3. Ethylene on ozonolysis produces ethylene ozonide, a cyclic compound, CH2 single bond O, single bond O, single bond CH2, single bond O. It is a ring compound or cyclic compound. It is ethylene ozonide, ETHYLENE, ethylene ozonide, OZONIDE. It is an unstable compound. It is ethylene. It is an unstable compound which on hydrolysis, addition of water, which is carried out in presence of zinc to form. This bond breaks like this. It is your one part, it is your another part. This O combines with this water molecule to hydrogen peroxide. CH2O can be written as HCHO, an aldehyde, that is a formaldehyde. It is also formaldehyde, so two molecules of formaldehyde plus O combines with this H2O to form H2O2, hydrogen peroxide. It is your formaldehyde. FOR, MALDEHYD. First member of an aldehyde, that is formaldehyde. It can be prepared when ethylene is treated with ozone. As an unstable cyclic compound, ethylene ozonide is formed. Ethylene ozonide, CH2O, single bond O, single bond CH2, single bond O. Ethylene ozonide is formed, which on hydrolysis, as it is an unstable compound, on hydrolysis, in presence of zinc, it forms two molecules of formaldehyde. This compound breaks like this. It is your first part, it is your second part, it is your third part. CH2O, that means HCHO. CH2O, HCHO. So two molecules of formaldehyde is formed along with H2O plus O combined to form hydrogen peroxide. So two molecules of formaldehyde, if you react ethylene with ozone, you get two molecules of formaldehyde. If you take CH3 single bond C H double bond CH. It is your propylene PRO PY LE. Propylene on ozonolysis, that is when it is added to O3, then propylene ozonide and unstable compound is formed. CH3, this double bond breaks and ozone link with this carbon and this carbon atom. CH3 single bond C H single bond O single bond O single bond CH2 single bond O single bond. It is propylene ozonide. It is also an unstable compound. Propylene PRO PY LE propylene ozonide OZO NID. It is an unstable compound. It reacts with water molecules H2O or hydrolysis, which on hydrolysis in presence of zinc, these molecules break. It is your first part CH3CHO. It is your second part CH2O, that is formaldehyde, and this O combines water molecule to form hydrogen peroxide. First acetaldehyde is formed CH3CHO. Second, it forms formaldehyde, that means mixture of formaldehyde and acetaldehyde along with water molecule, hydrogen peroxide. It is your acetaldehyde, ACEtaldehyde, acetaldehyde. It is your formaldehyde, FOR, formaldehyde. Ethylene on ozonolysis produces formaldehyde. Propylene on ozonolysis to form formaldehyde. A ketone can also be prepared from an alkane. If you take compounds like CH3 single bond C single bond CH3 double bond C single bond C 2 3 4 CH3 single bond CH3. It is also an alkene. The equation for this compound is there is 1 2 3 4 or 1 2 3 4. 2 3 dimethyl 2 3 dimethyl 2 3 dimethyl methyl propane butane, but hyphen 2 a double bond is present at the number 2 position. So 2 3 dimethyl bond 2 on ozonolysis when it is added with ozone. Similarly, first a ring compound is formed, which is an unstable ring compound. We call CH3. Twist this CH3 like CH3 C O C. Now twist this CH3 CH3 O. It is an unstable compound, unstable ozonide. Now this compound on hydrolysis addition of water, which is carried out in presence of zinc. This is your first part. This is your second part. CH3 CO. So here a double bond is formed in order to satisfy the tetravalence of carbon atom. CH3 CO CH3 is formed. Right hand side CH3 CO, same molecule. So two molecules of CH3 CO CH3, that is acetone is formed. It is your acetone along with your water molecule combines with this oxygen atom to form hydrogen peroxide, that is H2O. So we know that when ethylene ozonolysis produces an unstable cyclic compound ethylene ozonide, which one hydrolysis in presence of zinc to form two molecules of formaldehyde. Propylene on ozonolysis to form an unstable cyclic compound, that is propylene ozonide, which on hydrolysis in presence of zinc to form mixture of formaldehyde and acetaldehyde. But 2,3-dimethyl bond 2Ne on ozonolysis to form an unstable cyclic ozonide, which on hydrolysis in presence of zinc to form two molecules of acetone. So this is regarding from alkenes, how an aldehyde or a ketone can be prepared from an alkene. Then come to the number 8 general method of comparison. We come to the number 8 general methods of comparison. Number 8 from geminal dihalides. From geminal dihalides. From geminal dihalides. A ketone or an aldehyde can be prepared from a geminal dihalides. Geminal dihalides. What is geminal dihalides? There are two types of dihalides. One is your geminal dihalides, another is your vicinal dihalides. Dihalides means two hydrogen atoms. Suppose it is a carbon chain, C, single bond C, single bond C, single bond C. It is a carbon chain. If two hydrogen atoms, one connects to this carbon atom, another connects to this carbon atom. Two adjacent carbon atoms, two nearby carbon atoms. 1, 2. So it is your 1, 2 dihalogen compound. It is your 1, 2 dihalogen derivative. 1, 2 dihalogen derivative. Another one is your 1, 1 dihalogen derivative. Suppose 1, 2, 3, 4. This halogen atom 1, 1. It is your 1, 1 dihalogen derivative. 1 dihalogen derivatives. 1, 1 dihalogen derivative. One is called vicinal, another is called geminal dihalides. Geminal means 1, 1 dihalides. It is called geminal dihalides. Gem or geminal dihalides. It is the geminal dihalide. It is a vicinal 1, 2 dihalides is called vicinal dihalide. 1, 2 dihalide is called a vicinal dihalide. 1, 1 dihalogen derivative is called a geminal dihalide. A geminal dihalide, it is also two types. It means that if two halogen atoms are directly linked to the terminal carbon atom, either the last one or first one, terminal carbon atom, then it is called a geminal dihalides or terminal dihalides, terminal geminal dihalides. It can also connect with number 2 this carbon atom. So a geminal dihalides is of two types. Geminal dihalides may be a terminal geminal dihalides or a non-terminal geminal dihalides. Terminal geminal dihalides contains two halogen atoms directly linked with either the left hand, that is first carbon atom with the last carbon atom. A non-terminal means if two carbon atoms are linked, two halogen atoms are linked to the carbon, a single carbon atom, but not at the number 1 position, then it is called a geminal dihalides, non-terminal geminal dihalides. Two types of geminal dihalides. One is your terminal geminal dihalides, another is your non-terminal geminal dihalides. Then come to the part after. When a geminal dihalides is treated with aqueous caustic potash solution. Geminal dihalide is treated with aqueous caustic potash solution. Suppose if you take CH3, single bond CH, Cl, Cl. It is a geminal dihalides. 1, 1 dihalides. Dihalides is 1, 1, 1, 1 dichloro, 1, 1 dichloroethane. It is a geminal dihalide. When it is treated with aqueous caustic potash solution, caustic potash is your KOH, aqueous when it is dissolved in water, KOH, aqueous, two molecules of aqueous caustic potash solution, then KCl is replaced. Then KCl is replaced. And this 2OH part comes to this one. So CH3 single bond CH, single bond OH is formed and single bond OH is formed. Here two hydroxyl groups are directly linked to the carbon atom. It is an unstable compound. It is an unstable compound. Unstable. It loses one water molecule. This water molecule is eliminated like this CHO. So CHO is formed. CH3 single bond. CHO is formed. Acetaldehyde is formed. It is acetaldehyde. Acetaldehyde. Acetaldehyde is formed. If you take non-terminal, it is a terminal geminal dialect. If you take non-terminal geminal dialect, suppose you take Ca3, Ca3. If you these two chlorine atoms are directly linked to this position, so it is also geminal dialect. It is also geminal dialect, but it is your 1,1 dichloroethane. It is your 2,2 dichloropropane. 2,2 dichloropropane. First one is your terminal. It is a non-terminal dialect, geminal dialect. When it is treated with aqueous caustic potash solutions, aqueous caustic potash solution, then this K combines with this chlorine to form a KCl molecule. This potassium combines with this chlorine atom to form second potassium chloride molecule. As a result, -2 KCl, here you can write -2 KCl. So you can write -2 KCl, potassium chloride. Now CH3, single bond C, here one OH, here another OH. As this carbon atom is linked with two hydroxyl group, it is also an unstable compound. Unstable compound, and it will become stable by using one water molecule. And this water molecule can be eliminated like this. This OH combines with this H. As a result, CH3, single bond C, single bond O, single bond CH3. In order to satisfy the tetravalence of carbon atom and divalence of oxygen atom, you have to put a double bond here. So acetone is formed. A ketone, that is acetone is formed. So when 1,1 dichloroethane, we can prepare an aldehyde or a ketone from a geminal dialects. Geminal dialects are otherwise known as 1,1 dialects. When two halogen atoms are directly linked to the one carbon atom, then it is called 1,1 dialects. It is called geminal dialects. It is of two types, geminal dialects. That means it is a terminal geminal dialects, 1,1 dialects, or 2,2 like this. It is a non-terminal geminal dialect. A terminal geminal dialects produces an aldehyde, while a non-terminal geminal dialects forms a ketone. When 1,1 dichloroethane is treated with aqueous caustic potash solution, first an unstable compound is formed, which becomes stable by elimination of one atom molecules to form acetaldehyde. In second case, when 2,2 dichloropropane is treated with aqueous caustic potash solution, first an unstable compound is formed, which becomes stable after using one molecule of water to form acetone. This is about from geminal dialects. Then on to the number 9, that is from Grignard's reagents. Number 8, general method of preparation. Number 8, that is from Grignard's reagent. From Grignard's reagent, G-R-I-G, Grignard, from Grignard reagent. From Grignard's reagent, from Grignard reagent. From Grignard's reagent. Grignard's reagent is your alkyl magnesium halide. Alkyl magnesium halide is called Grignard's reagent. An aldehyde or a ketone can be prepared from Grignard's reagent. When a Grignard reagent reacts with HCl, that is hydrogen cyanide, first an addition product is formed, which on acidic hydrolysis to form an aldehyde. But a ketone can be prepared from Grignard's reagent by the action with an acid chloride. When an acid chloride reacts with Grignard's reagent, first an addition product is formed, which on acidic hydrolysis to form a ketone. Then comes the part how alkyne can be prepared. When a Grignard's reagent, that is RMGX, it is your Grignard's reagent, RMGX. When it is treated with hydrogen cyanide, HCl, HC triple bond N. Alkyl magnesium halide, it is your HCl. Your carbon is delta plus, nitrogen is delta minus. Because whenever one moves from left to right in the periodic table, electronegativity character gradually increases from left to right. Carbon atom number 6, nitrogen atom number 7, oxygen atom number 8, fluorine atom number 9. Fluorine is the most electronegative element. So electronegativity increases from left to right, that is from in a period. So carbon is delta plus, nitrogen is delta minus. Here in RMGX, magnesium is a divalent, that is an alkaline earth metal. MgX, it becomes delta plus, alkyl group is your delta minus. Now, this minus part, alkyl groups come to this positive part, and MgX come to this end to form an addition product. It is your Grignard's reagent, Gr. It forms H, single bond C, single bond R, double bond N, MgX. It is on acidic hydrolysis, that is H3O plus hydrogen ion, or you can write H2O oblique H plus. Now it is on hydrolysis to form an aldehyde. Aldehyde is your H2O. This bond breaks a double bond like this. Here O, H2 come water, H2O, H2 come to this part. As a result, RCHO is formed. RCHO is formed plus, here it is Mg NH2S. Mg NH2S. Here is your aldehyde, and it is an addition product. Addition product. If you take methyl magnesium, methyl CH3 magnesium chloride, it is a methyl magnesium chloride. When it reacts with HCl, HC triple bond N, then H single bond C, double bond N, MgCl, and the CH3 come to the same, CH, an addition product. It is a methyl magnesium chloride, methyl magnesium chloride plus HCl. It is an addition product. It is an addition product. It is on acidic hydrolysis, H3O plus. This O come to this end, H2 hydrolysis, acidic hydrolysis. It leads to form CH3, single bond CH, this O combine this part, CHO plus Mg NH2Cl. So acetaldehyde is formed. Acetaldehyde is formed. So when methyl magnesium chloride or a Grignard's reagent, when treated with HCl, hydrogen cyanide, then an aldehyde is formed. Here methyl magnesium chloride on treatment with HCl first form an addition product which on acidic hydrolysis to form acetaldehyde. Then come to the how a ketone can be prepared from Grignard's reagent. If you take Grignard's reagent when reacts with acid chloride, Grignard's reagent is your R, MgX. Acid chloride is your R, COCl. When Grignard's reagent is your RMGX. When Grignard's reagent RMGX react with an acid chloride is your RCOCl. RCOCl. It is your acid chloride. It is your delta plus. Here oxygen is delta minus and oxygen is more electronegative as compared with carbon. MgH is your delta plus positive part, alkyl group is your minus part. This R come to this end and MgX will come to this oxygen. So as a result, R single bond C, single bond R, single bond OMgX, OMgX, Cl is formed. It is an addition product. Addition product. It is acid chloride. Acid chloride. This is Grignard's reagent. This is on hydrolysis, acidic hydrolysis. H3O plus. This bond breaks from this part. OH, MgX, R, C, double bond O is formed plus MgX, Cl. Take it to. If you take methyl magnesium chloride, methyl magnesium chloride, when it reacts with acetyl chloride, Ca3CO, Cl is acetyl chloride, acetyl chloride, this is methyl magnesium chloride, methyl magnesium chloride, it forms CH3 C OMgX Cl CH3, an addition product, which on acidic hydrolysis H3O plus to form acetone CH3 C double bond O plus MgCl2 acetone. This is regarding your general method of preparation of aldehydes and ketones. Like general method of preparation aldehyde ketone सरी गला आपर मो नोट भी तुम मानको दे दोची आज नोट टा लिखि देबो ता पे एटा पढि मिलियो ता सहित कोन स्टूडेंट मते आर क्लास पछा